So we're going to sketch the graph of a logarithmic function, and we have to kind of think if we're going to do this without a calculator. So let's think about this. This tells us that we have a base 10, okay, and we can pick desired results that make sense. If our desired result, let's see here, sorry. If our desired result is 1 over 100, then we know that, if it's 1 over 100, then our exponent had better be negative 2. And if our base is 10 and our desired result is 1 over 10, then it's going to be negative 1. And our base is 10, So this is what they've done. They've said, oh, what happens if you want 1? Well, then the exponent better be 0. And then they plotted these points, okay? They said, I guess I should have labeled these. I recreated their table. That's all I did. And this is the y-axis. So, or the f of x, same thing. So, we're plotting the exponents. Y is our exponents. And so, as you go up, you don't go up very much. It's not like this or something, because you don't need very big exponents to make very big numbers. So it kind of flattens out, you can see. So let's think about this. We'll say, if my base is 2, here's my base. I'm going to think about this every time, so I'm putting it in my column here. If my base is 2 and my argument is, let's say my argument is, well, it can't be, I'm allowed to go to negative 2, huh? Negative 2 plus 2 is 0. Can I make this happen? Can I make the base 0? No, I can't do that. So I'd get an error for this. The result would be, there is no exponent that I can raise 2 to get 0. So that's not going to happen. Something's going on there. My base is 2. I just repeat that a lot because I know you know that, but maybe you'll forget. So then we'll say, what happens if I put a negative 1 with the 2 and I get a 1? Well, I can always raise anything to the 0 power to get a 1. Okay, then if my base is 2 and I put a 0 here with the 2 and I get a 2, oh, well, I can always raise something to 1 to get it to be itself. And then I say, you know what, I'm going to skip 1 because I don't like the look of that. I can do that, right? 2 plus 2 is 4. Okay, well, I can square 2 to do that. And then let's see what happens if my base is 2 and I say, how about 6 plus 2? That would be 8. And I'd say, oh, there's my 3. So, pick things that make sense. We're not using a calculator. And I haven't showed you how to use a calculator yet to use a base 2. Kind of on purpose, definitely on purpose, because I want you to think about this. And so let's see, my base is 2. And how about if I said 14 plus 2? That's 16. I can say 4. Okay, so I think I'm ready to go here. Here's my graph. Something was funny about negative 2. So there's something going on there. Here's negative 1, 0, 1, 2. This is not going to work out very well for me, is it? 4, 5, 6, 7, 8. I'm having to cheat a little bit. Maybe I'll stop at 8. Or no, 9, 10, 11, 12, 13, 14. Cheating a little bit, but not too bad. Okay. So, and this is my y-axis, and I'm going to say 1, 2, 3, 4. All right, so what's going on here? Well, when x is negative 2, that's a problem, so I'm not going to do that. How about negative 1? Well, I get 0, so there we go right there. And what happens when x is 0? Well, when x is 0, I'm at 1, so right there. What happens when x is 6? Oh, I skipped 2. What happens when x is 2? Well, let's see. I'm at 2. What happens when x is 6? Well, let's see. 1, 2, 3, 4, 5, 6. I'm at 3. Okay, so you can see I'm starting to flatten out here. And then I went out to 14 so I could say what happens when x is 14. And the answer is 4. Okay. And then we can kind of look up here. We know what happens when you get to the limit. In this case, the limit was 0. Can't be 0. In this case, we can't be negative 2. So we know there's an asymptote here at negative 2, because that's impossible. We can never get there. But we can get really close down here. So what we do then is we just try to connect these best we can. And we know it's going to flatten out. Poorly done. But you know it's going on up there and it's flattening. It's not going to completely flatten, but it's going to look pretty flat. Okay, so there we go.